Welcome to this episode. We are simplifying machine learning, deep learning, automation, generative AI, and agentic AI for you. In the previous episode, we discussed about data, inferential and computational paradigms, probability and conditional probability, Bayes' law, descriptive and deceptive statistics. We also discussed about matrices, linear algebra, and dimensionality reduction. Today we are diving deep into data science, machine learning, and generative AI. And we will see how all the concepts from the previous episode come alive in machine learning and generative AI. But there are so many terms floating around: AI, ML, DL, Gen AI. Let's get some simple definitions first to orient you. Artificial intelligence, AI, that's the big umbrella term. It basically refers to any machine or computer program that's mimicking human intelligence or behavior, essentially trying to make machines act smart like us. So AI is the overall goal: smart machine. Machine learning, or ML, is how AI often achieves that intelligence. It's a subset of AI focused on the idea that systems can learn from data, identifying patterns and make decisions with minimal human intervention, instead of programming explicit rules for every single possibility. So you let the machine learn from examples. Think of teaching a child to recognize animals or cat. You don't write a detailed program defining catness. You just show them hundreds of pictures of cats and maybe dogs and different animals, and they gradually learn the pattern that distinguish a cat from a dog. ML is like that, but it's learning from data. Deep learning, or DL, is a specific, very powerful type of machine learning. It uses algorithms inspired by the structure and the function of the human brain, specifically artificial neural networks with many layers, hence the word deep. It's like teaching using a structure that mimics the brain, allowing us to learn incredibly complex hierarchical patterns. Things like recognizing faces or understanding the nuances of natural language speech. It's a more advanced, layered way for the machine to learn complex things. Okay, AI, ML, DL. Which brings us to the really hot topic: generative AI or Gen AI. Things like ChatGPT or Claude that you may be using on daily. So you may be asking, where do they fit? Generative AI is a fascinating subset, mostly within deep learning. While a lot of ML and DL focus on understanding existing data, classifying images, predicting sales, detecting fraud, generative AI focuses on creating entirely new content. It learns the underlying patterns and structures from existing data like text, images, or music, and then uses that knowledge to generate brand new realistic output that resembles the original data but are novel creations. If MLDL is like an art historian analyzing paintings, Gen AI is like an artist creating a new painting in a similar style. Now, within machine learning itself, you often hear about two main approaches: supervised and unsupervised learning. Let us start with supervised. Supervised learning is like learning with a teacher. Data that's already been labeled with the correct output. Labeled data meaning that for each example input, the model is already told what the right answer is. So if you are building a model to predict loan approval, you feed it past loan applications and each one is labeled approved or denied. The model learns the relationship between the information features, applicant incomes, credit score, etc., and the known correct output, approved or denied. It learns from those labeled examples. In unsupervised learning, the machine is just given a bunch of data with no predicted label or correct output. Its job is to find hidden structures, patterns, or relationships within the data on its own. Now, how does it do that? It might group similar data points together, for instance. It's like a student exploring a brand new subject with no textbook, just a pile of articles and trying to figure out which articles discuss similar concepts and grouping them together without it being told what the groups are beforehand. In the business, this is really useful for things like customer segmentation. You feed the model all your customer data, purchase history, demographics, website behavior, and it might automatically discover distinct groups or segments of customers who behave similarly, even if you didn't know that those segments existed, which you could then use to do targeted marketing. Or it can also help you find hidden anomalies or just generally exploring complex data sets to see what structures emerge. Now let's circle back to generative AI, specifically the large language models. LLMs like ChatGPT or Claude that everyone's talking about. What exactly are they? LLMs are a type of generative AI model typically built using deep learning techniques. They are large because they have billions, sometimes trillions of parameters. Think of parameters or setting as billions of tiny internal dials or knobs that the model tunes and adjusts as it is learning from absolutely massive amount of text data like huge chunks of the internet, books, articles. One analogy is as having to adjust the desired temperature when you are in the bathtub using the hot valve knob and cold valve knob. You start opening both of them to a certain guessed amount, then wait a bit to see the overall temperature. If it is still not your desired temperature, you will adjust one knob or the other depending on if you want it colder or warmer. That's how each parameter can get adjusted in an LLM. The main goal of LLMs is usually to predict the next word or sequence of words in a piece of text. So they are prediction machines for language. Now, how do they actually understand text? Because they don't read like humans, right? So LLMs don't read in the way we understand reading. They process text by converting words into mathematical representations that we call word embeddings. So what does embedding mean? An embedding is a way to convert words, images, or any data into a list of numbers that captures their meaning, so that similar things end up with similar numbers, and computers can do. An embedding is like how your taste buds and nose convert complex flavors into patterns of nerve signals. Chocolate and vanilla both light up your sweet receptors strongly, so they end up with similar flavor coordinates in your brain, while chocolate and lemon get very different patterns. Just like your 10,000 taste buds convert any food into a unique pattern of signals that your brain can compare and remember, embeddings convert words or images into unique number patterns that computers can compare and work with. Essentially, each word gets turned into a large list of numbers or vector in a high-dimensional space. A vector is like coordinates. The key idea is that words with similar meanings or that are used in similar contexts end up having vectors that are close to each other in this mathematical space. Imagine assigning a unique flavor profile, a list of numerical scores for different attributes to every word. Words like mother and father might share high scores on family, but differ on gender, so they will be near each other but distinct. So it's about mathematical relationship between words. Now you may be thinking, when I type a sentence into ChatGPT, how does it figure out what comes next? It first breaks your input sentence down into those words embeddings. Then, using a complex mechanism often involving something called attention, it analyzes the relationship between all the words in your input. It figures out which words are most relevant to which other words in context and all the patterns it learned during its massive training. It calculates the probabilities for what the very next word should be. It then picks the most probable word or one of the highly probable ones and adds it. Then it repeats the process, considers the original input plus the word it just added, the next most probable word, and so on. So it's constantly predicting word by word based on everything that came before. Like when you're speaking, your brain isn't just picking words randomly, it's constantly predicting the most likely and relevant next word based on the sentence so far and your overall knowledge. LLMs do a mathematical version of that kind of prediction, but on a colossal scale. Now, how do they remember what we talked about earlier in the conversation? If I ask, for example, a follow-up question. That is through what's often called contextual memory or maintaining a context window. The model doesn't just look at your last message, it keeps a record of the recent turns in the conversation, both your prompts and its responses within its active memory. So it uses that conversational history as part of the input when generating the next response. This allows it to provide answers that are relevant to the ongoing dialogue and seems like it remembers what said earlier. Understanding how LLMs work help you use them more efficiently in business applications. Next, we will explore specific real-world business applications that are driving results today. If you're ready to experiment with ML, DL, and the techniques to address some business cases, join our hands-on sessions. I'll put the link in the comments. And see you in the next episode.